Hello, welcome to this class. Last week we were able to look at the application of skip counting, and we looked at application of skip counting by fives, skip counting by sevens, and skip counting by sixties, where we have questions like if one pile has five oranges or mangoes, how many mangoes are there in six piles? While in skip counting of seven, we related it to days, where 7 days makes 1 week. So how many days are in 2 weeks or something like that. In skip counting by sixties, we related it to time. 60 seconds making 1 minute, 60 minutes making 1 hour. And we recited the song for time, which says 60 seconds makes 1 minute, 60 minutes makes 1 hour, 24 hours makes 1 day, 7 days makes 1 week, 4 weeks makes 1 month, 12 months makes 1 year, 365 days makes 1 year, and 366 days makes 1 leap year. Now, today we are moving forward to addition and subtraction of numbers. Addition and subtraction of, let's say, of whole numbers. Then we put whole and decimal numbers. So we are looking at addition and subtraction of whole and decimal numbers. Remember, a decimal number is a number with a decimal point. And every decimal number has two parts, majorly. The whole number part and the decimal values, or three parts, including the decimal point itself. While whole numbers are our counting numbers, okay? Now, when we learned place value system, we looked at place value on the whole number part from unit to million, while on the decimal part, we looked at whole numbers up to thousand, where we said that 1,000 is interpreted in fraction form as 1 over 1,000, which is 0.001 in decimals. Okay? Having said that, let's look at this question immediately. The question says, find the sum of 4,347,296 and 732,879. Okay? Alright. So we said, question number one, we have find the sum of 4,347,296 and 732,879. Okay? Now, remember, when we talked about addition, there are some terms that depicts addition. A term like sum. So wherever we see the word sum, S-U-M, it means addition. So we have to add. And we are going to use our place value system in adding this number. Okay? Now, since the question says find the sum of 4,347,296 and 732,879, meaning that the highest place value in these two numbers is million. So solution. Let's bring out our place value system. Million, hundreds of thousand, tens of thousand, thousand, hundred, tens, and unit. Remember, in addition, arrangement is not important because 2 plus 5 is 7. 5 plus 2 is also 7. So arrangement is not important. But in subtraction, arrangement is very, very important because 2 minus 5 and 5 minus 2 are not the same thing. Okay? So bear that in mind. So here, okay, let's put these numbers 6, 9, 2, 7, 4, 3, 4. Let's arrange this. 9, 7, 8, 2, 3, 7. Now remember, in addition and subtraction of numbers, failure to arrange properly means that we are going to solve what? Beautiful nonsense. So we have to arrange properly. If we watch, 7 is in hundreds. If we take this 7 to millions, then we are already solving beautiful nonsense. Okay? So arrangement is very important. Okay? Now let's add. 6 plus 9. 6 plus 9 is what? 15. 15, right? So we write 5 down and we carry 1 to the next place value. Now let's add. 9 plus 7, 16. Plus 1 we carried from here. Becomes what? 17. So we write 7 and carry 1 again. 2 plus 8, 10. Plus 1, 11. We have 1, carry 1. 7 plus 2, 9. Plus 1, 10. So we have 0, carry 1. 1 plus 4, 5. Plus 3, 8. Are we carrying any number? No, because this is just a single number. 3 plus 7, 10. We have 0 and we carry 1. Then 1 plus 4, 5. Therefore, 4,347,296 plus 732,879 will give us 5,080,175. All right? Okay. Now let's look at this next question. It says the sum of two numbers. Let me write it out. Question number 2. It says the sum of two numbers. The sum of two numbers is 48,340,205. Full stop. If the smallest number is 10,739,825, find the bigger number. All right. Let's read the question again. The sum of two numbers is 48,340,205. If the smallest number is 10,739,825, find the bigger number. What do you think the question is talking about? Addition or subtraction? It has already given us two numbers. Let's say number A plus B is C. So they don't say that. The sum of these two numbers gave us C, which in this case is this number here. Now, if one of these numbers is this, find the other number. What do? We use the sum of the numbers to take away the given smaller number. Is that okay? So what we now do is we use the sum to minus the smaller number. So this is a subtraction problem. Alright? So we are going to use 48,340,205 to take away 10,739,825. Okay? So let's solve it. Let's solve. Solution. So we have 48,340,205. If you watch this question, I'm not making use of the place value system because I believe that by now we should be able to identify the place values of each of these digits without writing them out. Okay? So since this is 48 million, this is 10 million, meaning that the highest place value in both numbers is tens of million, right? So here I'll have 10, 7, 3, 9, 8, 2, 5. Well arranged. Then we minus. Because the question has given us the sum and gave us one of the numbers, asking us to find the other number, like a missing number. Okay? So we subtract 10,339,825 from 48,340,205. So let's go. 5 minus 5 is 0. 0 minus 2. Can 0 take away 2? No. Okay? So what we now do is we come over to the number here and borrow. We borrow 1. So if you borrow 1 from 2, what remains? 1 remains. Then that 1 you borrowed, you place it beside the number, and this 0 now becomes what? 10. Okay? 10 minus 2. Yes, it can go. 8. 1 minus 8. Can it go? No. We want to borrow. Can we borrow from 0? No, we can't because 0 is nothing. Okay? So what we now do, we come to 4 and borrow. Now when we borrow 1 from 4, what will remain here? 3. We've put that 1 in 0, not in 1. Don't jump any number when placing the number you borrowed. Okay? So when we now put it here, it now becomes 10, no more 0. So we now borrow 1 from the 10, and 9 will remain. We now put the one we borrowed to 1, it becomes what? 11. So 11 minus 8, 3. 9 minus 9, 0. 3 minus 3, 0. 3 minus 7, can it go? No, it can't go. So we come to 8 and we borrow 1 from 8, 7 will remain. We put that 1 before 3, it becomes 13, no more 3. Now 13 minus 7 is what? 6. 7 minus 0. 7. Because anything take away 0 is that thing. 4 minus 1. 3. Therefore, the bigger number is 37,600,380. Alright? Okay, let's look at this example. It says, find the sum of number 3, example number 3. Find the sum of 124, 108, 108, 191, 128, and 109. So this is actually simple. And we are going to add it once. Now, there are 2 ways to do this. You can either be adding the numbers in twos, or you add all of them together. So let's add all of them together. Solution. So here I have 124, 108, 191, 128, 109. You are adding all of them. Are you seeing? Like I said, you can either decide to add this plus this. Then to your answer, you add this. To your answer, you add this. To your answer, you add this. Or you add all of them together. So we are adding all of them together, meaning that we are going to add 4 plus 8 plus 1 plus 8 plus 9. We write our answer and carry whatever number we need to carry. Is that understood? All right, let's go on. 4 plus 8, 12. 12 plus 1, 13. 13 plus 8, 21. 21 plus 9, 30. So since here is 30, we write 0 and carry 3. Alright? Now let's add 3 plus 2, 5. 5 plus 0, 5. 5 plus 9, 14. 14 plus 2, 16. 16 plus 0, 16. So we have 6 and carry 1. Now let's add. 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, 5 plus 1, 6. So here we have 6. So we now notice that the sum of 124, 108, 191, 128, and 109 is 660. Okay? So let's look at this final example. Let's look at this example for whole numbers. Alright? Number 4. Let's look at example number 4. Example number 4 says, subtract 3 scores and 3 dozens from 2 grows. Subtract 3 scores and 3 dozens from 2 grows. So the first question we need to know, or we need to ask ourselves is, what are scores, dozens, and grows? Okay? Now these are words that has a representation of numbers. Now what we need to know is that 1 score represents the number 20. 1 dozen represents the number 12, and 1 gross represents the number 144. Okay? So whenever you hear someone says a dozen, simply means that he's saying that whatever he or she has is 12 in number. Now when the person says, I have 1 score of ice cream, so if the person has 20 ice cream. If the person says, I have 1 gross of biscuits, meaning that the person has 144 biscuits. Okay? So, solution. Like we said, 1 score equal to what? 20. 1 dozen equal to what? 12. 1 gross equal to what? 144. But in the equation, it gave us how many scores? 3 scores. Meaning now that 3 scores will be what? 3 times 20, which is what? 3 times 20, which is what? 60. 3 dozens will be what? 3 times 12, which is what? 36. 2 gross will be what? 2 times 144, which is what? 288. Now we now come back to the question. The question says, subtract 3 scores and 3 dozen. So 3 scores and 3 dozens means 3 scores plus 3 dozens. And 3 scores plus 3 dozens is now 60 plus 36. From 2 gross, meaning 288 minus 60 plus 36. Alright? So I can put it as 2 gross minus, I open a bracket, 3 scores plus 3 dozens. How you say it? Now 2 gross is what? 288 minus, open your bracket again. 3 scores is what? 60 plus 3 dozens is what? 36. So what we now do here, remember, you first of all do the addition in the bracket before you do the subtraction. Now, this now becomes 288 minus 60 plus 30, 6. 0 plus 6, 6. 6 plus 3, 9. Meaning that 60 plus 36 is 96. So we now subtract. 288 minus 96 will give us what? 192. So therefore, when we subtract 3 scores and 3 dozens from 2 gross, we have what? 192. Hope you understand that. Alright. Remember to send me your questions, and when we meet, I'll answer those questions. Now let's look at adding and subtracting decimals. Okay? Addition and subtraction of decimals. Let me clean this place. Remember, I said that for if 2.4 is a decimal number, now from this decimal point, this part, this is left hand side, this part is right hand side. And I said a decimal number is divided into 3 parts. This side is called decimal values. Decimal value part. Why this part is the whole numbers. Right? Then comes the decimal point. I said it. So this is a decimal number. Now, in addition and subtraction of decimal numbers, the decimal point must be on a straight line, while the whole number part must be under itself, ranging from units, tens, 100,000, tens of thousands, hundreds of thousands, millions. The decimal value part will start from its tenth, hundredth, thousandth. Is that understood? So once we arrange them properly, then we are done with the measure of the work. We then do our addition and subtraction of the given numbers. Alright? Okay. Let's say example 1. Solve the following. Solve the following decimals. Solve the following decimals. A 213 plus 41.013. Okay? 341.213 plus 41.013. Remember, the decimal values are pronounced digit by digit. Okay, let's solve. Solution. Here I have 341.213. Remember, the points must be under themselves. Now, this is unit times 100. This is unit tens. So what comes under 1? 4 under 4. Please don't go and put your 4 here and 1 here, then put 0 here. No, this becomes 410. No more 41. Okay? So remember your place value. Remember your place value. Then here I have 0, 1, 3. You add. Now we add 3 plus 3, 6. 1 plus 1, 2. 2 plus 0, 2. Bring down your points. You bring down your points. 1 plus 1, 2. 4 plus 4, 8. Bring down 3. If I like, I can fix 0 here. Then 3 plus 0 still gives me 3. So it's that simple. Just arrange them properly. Arrange them properly. Okay? Now let's look at this. Number 2. That's B. Let's say 8,491.01, or rather, let's say 0.7 plus 59.321. Okay? Let's solve. Solution. 8,491.7. Remember, this is unit tens, right? So I have unit tens and unit point. Point under point. Now, some persons might be confused. Since this one has only one decimal value, this one has 3 decimal values, where will this one be? Some persons might start writing this like this. Now put 7 here. No. If you put it here, that means there is 0, 0 here. And this number now is not the same as this number. This 7 is in the 10th place value. It's not. But if you place it here, it's not on the 1000th place value, which is not now wrong. Okay? So always remember your place value. It keeps being on the 10th place value. Now we can have 0, 0 here. Alright? Then let's add. If we like, we can fill here with zeros. 0 plus 1, 1. 0 plus 2, 2. 7 plus 3, 10. We write 0 and carry 1. Bring down your points. 1 plus 1 plus 9, 11. We write 1 and carry 1. 1 plus 9, 10. 10 plus 5, 15. We write 5 and carry 1. 1 plus 4, 5. Plus 0, 5. 8 plus 0, 8. So our answer becomes 8,551.021. Are you seeing the arrangement? The idea is in the arrangement. Okay? Arrange properly. Remember that your decimals must be on the same line. And your place values are also in consideration of the arrangement. Decimal under decimal, then the number immediately after the decimal point, under the number immediately after the decimal point. Alright? Okay, let's look at this example number 3. Let's look at example number 3. Example number 3. All right. Here the question says 782,453 minus 0.01 minus 249,658.457. 0.457. We need to subtract, right? Yeah. Let's solve. Solution. 782,453.01. Then we go 249,658.457 minus. Now we can put 0 here. I see the arrangement. Very important. Okay? Now let's subtract. 0 minus 7, can it go? It can't go. So you borrow 1 from here, 0 remains, put that 1 here, it becomes what? 10. 10 minus 7, 3. 0 minus 5, can it go? No. Can we borrow from this 0? No. Can we borrow from 3? Yes. So we borrow 1 from 3, 2 remains, we put that 1 here, becomes 10, right? We borrow 1 from 10, 9 remains, we put that 1 here, becomes what? 10. 10 minus 5, 5. 9 minus 4, 5. Bring down your decimal points. 2 minus 8, can it go? No. You borrow 1 from 5, 4 remains, put that 1 here, becomes 12. 12 minus 8, 4. 4 minus 5, can it go? No. We borrow 1 from 4, 3 remains, put that 1 here, it becomes 14. 14 minus 5, 9. 3 minus 6, can it go? No. You borrow 1 from 2, 1 remains, put that 1 here, it becomes 13. 13 minus 6 is what? 7. 1 minus 9, can it go? No. You borrow 1 from 8. 7 remains. You put that 1 here, 11. 11 minus 9, 2. 7 minus 4, 3. 7 minus 2, 5. Therefore, our answer is 532,794.553. So this is the concept of subtracting and adding decimal numbers. Remember, every decimal number is made up of 3 parts: the whole number part, the decimal value part, and the decimal point. The whole number part, the decimal value part, and the decimal point. The whole number part starts from the unit place value, then up to millions, billions, tens of trillion. The decimal value part starts from tenths, hundreds, thousands, tens of thousands, hundreds of thousands, and it continues going like that. When adding or subtracting a decimal number, make sure that the decimal points are under themselves and your place values are considered seriously. The decimal points must be on the same line, and the numbers after and before the decimal point must be on the same place as the numbers, meaning the unit must be under unit, the tenth must be under tenths, and so as the other place values. All right? Okay. So this is the end of this class. Let's just look at these two concepts for now. Then when we meet, we will now extend it more to word problems involving addition and subtraction of whole numbers and decimal numbers. Okay? So I'll see you. I'll give you assignments to solve for me. And remember, solve your assignments. I will snap and send to your mom. Then I'll snap and send. Then you solve and send back to me, just like you did last week. Okay? So see you in our next class on Saturday. Bye.